welcome you all once again. And I would like to introduce TG, which is Krish has formed this company along with two young, energetic Nandu and Anandu. So it is founded as by young and dynamic professionals who actively contribute in various national and international standard committees, such as BAS, IEC Standard Committee. So the company mission is to support the electrical industry in designing low voltage system that comply with National Electrical Code NEC of India 2023 and also IEC standard. And myself, Dominic, and we've been regularly seen in the workshops and seminars, and I've been from the fire industry, so I'm taken a lot of interest in the electrical safety because we keep complaining about electrical short circuits, poor design, poor maintenance of electrical. So I'm trying to understand with these young professionals, and along with Mr. Gopakumar, we have completed 27 seminars. So I've been part of this, and also I'm a founder of FSA, Fire and Security Association of India, and Focus, of course, another integrated society for all the critical services. And I'm also founder of National Federation of Electrical Engineering for Safety. And the last, with close to my chest is my heart, Indian Society for Brave Hearts, where we wanted to recognize people who sacrifices their life for the sake of safety. So, so with me, my colleague and the speaker, very energetic when he comes and speak on the stage. He electrify the whole conference hall. So that is Krish Theobald. He is the technical director at TG Electro. Krish is a meticulous electrical designer who has no nonsense approach towards electrical safety. His expertise lies in LV electrical installation design for commercial and large scale domestic installation. His specialization is achieving on-ground compliance with IEC 60364 based on National Wiring Regulation IS 732 and SP 30. So he's a member of BIS ETD 20 and ETD 50. He's also a member of IEC TC 64 and MT1 and MT12. And he is the guest faculty for NEC capsule courses of BIS in NITS Noida. So this is for you, the ladies and gentlemen, those who have joined us to listen to this wonderful introduction of the software, which is developed by Mr. Krish. And over to you, Krish. The whole audience we have over 550 people watching this, and quite keen. When we invited, we have a limitation in accepting invitations, so we cannot go beyond 500, but it is crossed 557. So over to you. Let's get enlightened by your presentation.
Yeah, thank you very much. So yes, before we bring you the software that we've got from Modicsoft, we'll just give you a little bit of a brief introduction on the subject. So I'll just share my screen. Right. So simplifying electrical design. So when we do electrical design, it's a very tedious process. Generally, there are a lot of factors to be considered. But aside from all of that, you obviously need to know everything you need to know and to ensure that the design is compliant to the National Electrical Code. But there's a lot of duplication of work happening. Like I said, most of the times people, they work on, they use a spreadsheet. Well, they firstly use a CAD software to model the schematic or the single line diagrams. Then after that, they run the calculations on Excel usually. But these calculations are oftentimes quite tedious, and I'll show you what I mean. Also, any mistakes in their calculation, I mean, Excel is not an electrical design software, so yeah. And then on top of that, the actual accessories and the modeling is done in usually CAD or BIM software. Now, each time you want to make a single change, it has to be made everywhere. So it's quite a tedious process. Anyways, so what does electrical installation design generally look like? So the first stage is we have to identify our loads. So for example, what sockets do we want? What lights do we want? What motors, what machines do we want, etc. And what are the characteristics? So, socket outlet would be, leave it quite variable because we don't know what one will plug in. But a light would have a certain characteristic. A motor would have a certain characteristic. They have a certain current rating. They have certain starting current, so on and so forth. Their locations. So generally, we'll have a floor plan. If it's any big project, then you'd have a floor plan. You'd say, I want sockets here, I want lighting here, I want the control and you know monitoring devices here. I want my motors here, my air conditioners here, so on and so forth. Then it's a matter of assessing, given that our loads are distributed in a certain manner, where is the best place for our incoming supply? Sometimes you don't really have a choice in this. The discount gives you a supply where it is, so it's that. But other times, if you have a transformer, say, then you can choose where to bring your LV supply. Then, is there a need for standby supply? Fortunately, in a lot of parts of the country, we don't have a constant supply of electricity. So, we may need a standby supply there. Furthermore, if it's a critical load, for example, then also we need a standby supply. That's basically maybe a backup or run in parallel with the discom. Then, so whatever supplies we have, what are the supply characteristics? So, if it's a LV supply, we'd have our earth fault loop impedance, we would have our maximum short circuit current, and obviously, what is the normal current for load? If it's a transformer, you have your percentage impedance, your FC, all of these things. If it's a solar PV system, similar factors. What's the maximum current, fault current contribution? What is the earthing arrangement, obviously, even for LV supplies? Once we have all this information, we have to put it together and create an outline. So this is done in two ways. Number one, we create a schematic starting with our source. I'll show you some examples as well. Going to your main distribution board, sub-distribution boards, loads, etc. Cables that you want to put in, so on and so forth. Where do you want to run the cables? This is generally done on the floor plan. Once you decided what we want where, we need to now select our protected devices and assemblies. So this could be your circuit breakers, fuses, RCBOs, the actual panel boards, your distribution boards, so on and so forth. Then obviously it's a matter of selecting cables. So when we select cables, there are four things that we generally look at. Number one, we have current carrying capacity. So obviously, how much current can the cable carry in normal operating conditions? Voltage drop. So is the cable able to provide, rather, is the arrangement able to provide an adequate voltage to connected equipment, voltage that the equipment actually requires to function? Most installations have the protective measure of automatic disconnection of supply for protection against electrical shock. And as we all know, the key thing there is earth fault loop impedance. And obviously, we have a supply earth fault loop impedance, but the value of earth fault loop impedance and the contribution of fault current at the extremity determines whether the device will disconnect or not. So we need to adjust the cable size to ensure adequate earth fault loop impedance is present. We also have the cable size and for prospective fault circuit current. So, for example, you've got your, like I said, earth fault loop impedance, you're talking about at the extremities. So, minimum fault current. But towards the origin, so at the distribution boards closer to your protective devices, we've got a relatively high prospective fault current, maybe prospective fault current, maybe prospective short circuit current. So it's a matter of can our devices interrupt that current, and when the device interrupts that current, so your MCCB, your fuses, your circuit breakers, whatever, can the cable withstand that let-through energy? And this calculation has to be run for your entire, so from your minimum short circuit current or fault current to your maximum short circuit current and fault current. Lastly, what are our provisions for isolation and control? So this may be something as simple as switches for your lights and sockets, or it may be, for on machinery, you want to have some sort of control circuits, e-stops for safety, stuff like that. So this is the whole process, but what we often overlook in India, unfortunately, is we don't really select protected devices and assemblies. We just tend to use what is available. Sometimes when we do, it's more of a thumb rule rather than an actual calculated approach. We've also got a cable selection for current carrying capacity. So we often select cables for load. We don't actually follow the correct process, and I'll show you what that means. Voltage drop, yeah, we do it, but how exactly you do it? Let's look at it. Earth fault loop impedance, we don't really do, unfortunately. And those that measure earth fault loop impedance, they measure after the installation is erected, and then, well, you can't really do too much once the cables are already installed. And obviously, we do talk about protected devices for prospective fault current and short circuit current, but cables we don't really think about so much. So, what are our protected devices? We've got the MCBs that generally we use, or we also have circuit breakers like your MCCBs and fuses. These have certain tripping characteristics. And we've got your RCDs. So, overcurrent protected devices and residual current devices. Now, we know that there are the AC, A, F, and B, but we shouldn't be using the AC. So, these are what are the protected devices we should be using? So this is just, yeah, we've got your MCB here, your RCBO here, and then your RCBO AFDD as well, which is now required in certain locations like domestic dwellings. Assemblies, this is an important one. We tend to select protective devices rather than assemblies because remember the product that we use in the installation is an assembly. So we have the 61439 series of standards. Now, if it's to be operated by ordinary persons, the assembly, which is the protected device bus bar, everything together has to comply with 61439-3. So we have to select our assemblies accordingly as well. Current carrying capacity. Now we have your tabulated values, which are the manufacturer says, 2.5 square mm in carry 20 amps, for instance. However, these values are very rarely what the installation actually will use because we have to correct to our effective current carrying capacities. Most importantly, we have the factor of grouping. So how many cables are grouped together? So, I often hear that in a single 25 millimeter conduit, we have something like 6 circuits, which is entirely ridiculous. Not only because it kills the cardinal rule, which is only occupy 35% of the conduit's internal cross-sectional area, but because we're now affecting the cable's heat dissipation greatly. Ambient temperature. So, what is the ambient temperature? So, the cable is tabulated to carry a certain amount of amps. It's tabulated to do so rising from the ambient of 20 to the maximum operating of 70. But if the ambient itself is higher at say 40 or 45, then the cable cannot rise that much anymore. If you bury the cable in soil, so the soil's ability to dissipate heat is also a factor. And if you have surrounding insulation, that's also a factor. So a lot of new buildings are seeing this now. Obviously, how deep you bury it also matters. And if you're using a fuse, such as an HRC fuse or a KitKat fuse, then there are certain other factors that kick in as well. I'll show you some more details. So grouping, well, we often see installations like this where the cables are very neatly tied up inside, but unfortunately, very seldom are the actual grouping factors taken into account. And you do this, you're essentially impeding the cable's ability to dissipate heat and maintain that maximum operating temperature, usually 70 degrees. On the other hand, you have this cluster where you've got so many conduits and so many cables. Same story here. Well, this is an image from a friend of mine in the UK, Tony Stillwell. So, if you want to actually mitigate grouping, in most cases, you can do this by maintaining 2 times cable diameter spacing between cables. So, it would be something like if you have a 10 millimeter cable, just maintain 20 millimeters between. Then, in most cases, you don't need to, take a grouping factor into account. We look at our cable shafts. Unfortunately, this is what we see. Simply maintaining a 2 times cable diameter spacing in most cases mitigates the need for grouping factors. So, ambient temperature. Like I said, assume we are 30 degrees outside, 30 degrees inside, right? When you are running the cable, say at a maximum operating temperature of 70 degrees Celsius, 30 degrees outside, 70 degrees inside, this is a 40-degree rise in temperature that the cable can handle. However, in most parts of the country, we see temperatures up to 45 degrees Celsius as ambient. What this means is that the cable can now only rise by 25 degrees. So earlier it was rising by 40 degrees, now it can only rise by 25 degrees. So obviously the current carrying capacity has to reduce. If you don't derate, generally you start to see things like this, bad burns, complete degradation of insulation. See, we have a thumb rule in India sometimes where we say lighting, 10 ampere MCB, 1.5 square mm, air conditioning 16 ampere MCB, 2.5 square mm, sockets 2.5 square mm, 16 ampere. But if we consider the two main factors, which are grouping and ambient temperature, you see that in most cases, the thumb rule does not actually work. So you need to actually size up much, much higher. Conductors as well, we've got our class 2 and class 5 conductors. We know that we have to use class 2 only in India. Uh, Voltage drop, of course, we've got 3% and 5% for public supplies, 6% and 8% for private supplies. Earth fault loop impedance, very important again. So, the earth fault loop impedance has to be lesser than or equal to UO by IA, or ZS into IA less than or equal to UO. In India, we apply a two-third factor to correct for temperature. So that's that as well. In an insulation, we need to know the Z supply, ZL, Z1, Z2, and ZP. And essentially, you need to know all of this to calculate what your earth fault loop impedance is here. So when a fault occurs here, the magnitude of fault current is dependent on all of these separate factors. Prospective fault current, I squared T shall be lesser than K squared S squared. So the amount of let through energy has to be less than the cable can withstand, and it has to be ensured for short circuits occurring at any point in the circuit. So generally, this is done in a graph. The manufacturer gives you a line saying our device will allow a certain amount of let through energy for a certain amount of fault current, and this is your minimum fault current. So this will be a short circuit current at your extremity. This is your maximum closer to the protected device, and this is the withstand of the cable. So does our device ensure that let through energy is always less than the cable can withstand? So in this case, yes. Now, how do you do all this? So we can do it longhand. Obviously, I'll show you some spreadsheets as well. And yeah, it gets pretty complicated. Or you can do it with the software. So let me just show you what the what we're really looking at. So you see, we've got here our cable type, number of conductors, insulation, so on and so forth. What is the protected
Sorry to
device we're
interrupt, Krish.
using? Yes,
Could you please speak a little more louder? We are
a
getting a lot
little
of
louder.
messages in the chat box. Yeah, little louder.
Okay. Let me just see if something is affecting the volume I'm speaking at. Uh, okay, little louder it is then. Right. So we've got, cable type. What is the cable? What is the maximum operating temperature? What are we running it to? Cross-sectional areas. What is the protected device? Then, what is the earth fault loop impedance? What is the resistivity of the cable? So then what is the earth fault loop impedance going to be? Is it okay or not? Then is the protective conductor selected? Can it withstand the conductors? The electrical energy led to a protective device, is it okay or not? You've got your current carrying capacity, obviously, so all your rating factors. What is the voltage drop? Again, what are we running it to, and is it okay or not? So maximum demand and diversity is also there. A lot of things are there. Really. Anyways, so coming back to the software, let's just open it up. So this software is basically developed by a company called Modicsoft, which is based in Cyprus. They majorly make for the UK market. So the way it works really is that, as you know, I've been in the UK for electrical design. And essentially, what I figured is, well, see, knowing the standard is one thing, but saving time and ensuring that you're not doing any donkey work essentially is another thing. So the software is pretty much the gold standard to use in the UK and a lot of IC markets as well. But in India, even if we want to comply with the standard, we don't really have access to a software. So we've partnered with Modicsoft to bring this to India, developing an engine for NEC. Anyways, so uh, let's just go through a very, very simple situation. So if I were to consider a simple source, I'm just going to add a source for now, and then we will look at the actual model that we will develop. So say it is a simple user-defined source. We've got certain earth fault loop, prospective short circuit currents, respective earth fault currents, and obviously symmetric short circuit currents. We've set our voltage supply. It's a TNS installation, let's say. Now, if I were to go to a, excuse me, if I were to model a particular installation, for example, this installation here. So pretty simple. So the first thing I will do is I will also get my CAD plan. So if you just allow a moment for this. Yeah, participants raising your hand, we will get to you once we've completed. Obviously, Nandu and Lakshmi are there to monitor what's coming up as well. So the first thing I will do is I will add an external reference. So we've got the building here. Now, once I've added the external reference, obviously I want to use the CAD plan to calculate our lengths. So the first thing I'm going to do is I'm going to use a reference length. For example, I know that this is 5 meters long. So what I will do is I will first select the external reference, which is a CAD file. I will scale it, select a known distance, in this case 5 meters. So draw a line, 2 points, that should be 5 meters. So I'll draw, so excuse me. Yeah, 5 meters. Yeah, that's fine. So I'll go here, to here, and now scale the drawing. So for example, now we can see that the drawing is now scaled. So if we look at any of the other lengths, for example, this is 2.5 meters. If we measure the actual length, we will get the right value, 2.5. So now that we've scaled our drawing, let us, let us be creative because we don't have any, it's not an actual project. So, let us assume that this existing panel room is what we will use. So if we shut this back, right, we've got our supply. It's like this, and let's introduce a distribution board, 3-phase board. Now, if we look at the original schematic, we have a 4-core 16 square mm aluminum armored cable. So let us go ahead and select that. So I am going to select Indian standard, IS 7098 aluminum. We'll run to 70, and we'll clip it direct, and we will do 16 square mm. Now you see the software is immediately giving me a warning because at this point I've got 22 kiloamperes of short circuit current that is possible, but our device can only, the current default device can only do 10. Okay, so yeah, well, in this case it's an MCB, but because we have assumed a higher short circuit current, we're just going to select an MCCB in this case. So uncheck all, MCCB. Let's say, for example, it's a Siemens, and let's select a nice little ETU 350 product, set it to 100 amps, and we will down set it to say something like 53. Brilliant. Now, you see, it's giving me a warning that the 16 square mm is not enough because I need a minimum of 63, but in this arrangement, the 16 square mm can only carry 51. So that's where this comes into the picture. I can select a reduced 3.5 core as well if required. Now, if I save, see the warning disappears. Now I've got my cable, and now this is going to be an isolator here as well, and that's fine. Now let us model this on the actual board. So if I model, I want a dB, I want it here. I will put that here. Now, first thing is, this is the floor layer. We want this to be in the electrical layer. So move to page and electrical. So this is our distribution board. Now I will essentially assign this distribution board to that in the schematic. So I will go to dB1, assign. So now essentially I've got, this is my dB1 in my installation. Now, if we take a circuit, for instance, back to our SLD that we've got. So we've got some drilling tapping machines here, 1.5 kilowatts each. So say, for example, it's a 10 ampere MCB and 1.5 kilowatt load. We want to use, well, this is saying use a 4 square mm copper armored cable. So let's do that. This is a insert. This would be a final circuit, 3-phase. So let's again look at our schematic. It's a 10 ampere three-pole MCB. So it's, for example, say you want a Siemens, uncheck MCB. So say, for example, it's the 5SY series. So, or the 5SL, let's keep it simple. Say it's a type B in this case, or actually drilling machine. So we will take a slightly different device. Let's take it as type C10. Actually, hold on one moment, please. Yeah. Higher. Yeah. Now, and let's say that this run, let's say the run was 20 meters. So the cable is actually running 20 meters. And again, Indian standard, copper, multi-core, so I7098, we'll run it to 70. Now, supply changes. Now, once again, you see the software is giving us a actual error because the device selected is a 6K device, but actually we would have 10.28K there. So now, again, this is what the software does. So now if you see, if I were to, sorry, one moment, please. A little louder, I see. Okay. Right. So you see the issue that's come up, which is how the software is quite intelligent, is that essentially I've selected a protected device with a 10K braking capacity. But the software has calculated that at this particular point, actually I have a maximum phase fault of 10.2K. So if I now change the protective device, this fault will go away. So protective device change. If I, it's only 6K here, sorry, yeah. If I now say take a different device, say an Eaton device, MEM Shield 3, say I do a 15K type C, 10 amps, and now I refresh, that fault goes away. So the software is quite intelligent in that sense. Anyway, so now we've selected the load. We need to obviously enter the what we call our fault current. What is our actual load? So this tells us that we want it to be 1.5 kilowatts. So I will enter here 1.5 kilowatts. Say I have a power factor of 0.8, static, but okay. Total load, and say I have a third harmonic value of 15%. So yeah, now it's giving me a warning saying the power factor is low because it's below 0.8, and that's fine. Now, so I've got my circuit here, but what does it look like on our CAD plan? And this is where it gets really interesting. So say, for instance, this actual drill machine, drill tag unit is this one here. So I will just put in a other final circuits, and I can put in a fixed device, so say I put that there, and say right next to it, I have this here. Now, how do I wire this essentially? So the software can do it in two ways. There's a draw wiring, wiring by selection. So firstly, let's see what height we want this to be actually set at. Yeah. So go to properties. Currently, this is set at an elevation of 0 meters. But say I want to set it to 1.4 meters, right? If you actually view it in 3D, we actually got it at 1.4 meters as well. Now, how do we actually wire this? So obviously, you can put in cable trays, whatever we want. But let's say that we actually wire it at the ceiling. So that'll be 3 meters. And we wire it from DV1. So let's run it just around this wall, just like this. And let's say it had to go I don't know, down somewhere here to cross. Go all the way like that. And actually now it goes, terminates over here. So now we've actually done our wiring. Now the interesting thing is, if I select this wire, I actually now know how long it is in 3D. So for example, if I select DB1 and change this to this and assign it, you see now I know that it is 56.1 meters long. I haven't assigned this actual circuit, this actual point of utilization. So once I do that, so now you see I've got one final circuit point and 56 meters. So now if we actually view this in 3D, you see I've got from my DB to my actual point of utilization. The interesting thing is now because I've assigned it, this phase neutral conductor, let me just make sure that it is assigned again. Yeah, I have to apply it, my bad. Apply to circuit. There we go. Now, if I go to FC1, you see 56.01 meters is my length. So this affects my calculations for my earthing. It affects my calculations for the protected device, correction factors, everything. When we talk about correction factors, right? Say I've got 4 circuits next to each other, ambient temperature of 45 degrees. And well, it's not a problem for in this case because our load current is relatively small as well. So yeah, that's how it works. Now, obviously, this has done the calculations according to everything. So, for example, what is my fault current at the end point? What is my fault current at this? What is the fault current at the start point? How much electro energy is there? So we can, if you go into our selectivity studies, you can actually see here that for both conductors, this is the fun for our this is for our phase conductor, this is for the armor. We are always allowing lesser, the device is always allowing lesser let through energy. So that is your thermal withstand analysis essentially. Then if we go to our say we go to a protective conductor, it says this is the conductor, this is the length, this is the cable, this is the armor, this is the minimum current carrying capacity required. So whatever cable ID we want to put, is it an FR cable? Is it run to 70 degrees? Is this the maximum operating temperature? Are you on any extra course? So on and so forth. Now, say for example, in India, it's very common to have a external, not only utilize the armor, but an external conductor. So I will say core of the armor and separate conductor. Say it is touching. We want a copper conductor, for instance, and we set this to another 4 square. So now we're good. If I can do. Now let's look at one of the other ones. So in this case, these are all drill and tap machines. So I am going to switch it up a little bit because this was a relatively easy circuit to model. So say for example, I want to install a socket outlet circuit. So say I'll do that here. I will insert a circuit, a final circuit, single phase. We'll choose a D16 RCBO this time because you'll need additional protection. Yeah, you can select type AC, AF, and you see by default it selects type AC. And say we run it in steel conduit, so metallic conduit, heavy, 25 meters, and we can put in a number of bends that will do that calculation as well. Okay, now it's asking us, is the circuit protected against mechanical damage? It's a requirement of the standard. So if I say yes, we're good to go there. What is a circuit? So say for example, it's a radial socket outlet circuit. So I select that. I'm assuming say 200 watts per circuit. And how many circuits, I don't know. Well, let's look at it in our plan. So what are we looking at? Now say it is for a computer, right? So let us assume that we have this, I don't know, let's see. How can we be as creative as we want to be? let us say that people are deciding to work on some computers over here, for example, in this open area. So we add in our sockets. Say you want to add in a single socket or a double socket. Say we add in a double socket. So, it allows us to add it here, here, here. Now, what I will do is, obviously, aside from a socket, I also need some other things. So, for example, each socket I install, this is to generate your bill of materials. I'm going to need, say, for example, a back box as well. So, if I go into our one moment, please. I go into our item codes. I can start adding items. So if I say add, I say 8 module back box add. And per socket, I want one back box. Then say per this thing, I also want some ferrules, lugs. So say I want to add, forget lugs, let's use a better example, connectors. So 3-way connector. Let's say I want to do 2 of the 3-way connectors and 1 of the 5-way connectors. So now I say I use all of this. So now you see, for each socket outlet that I'm adding, I get all of this. And I can select all of these. So another thing I can do is I can right click and say select similar. So I've selected similar. And now item codes, I've got this all selected. So now how do we actually get the bill of materials? So see, if I click on this summary, I say 3 back boxes, 6 3-way connectors, 3 5-way connectors. So now I've automatically got this bill of material as well. But now how do we actually correlate this? So to the actual schematic. So if we go to our design and we say wire by, let's actually say what height we want this at. So yes, raised hands, Nandu and Lakshmi all are monitoring the chat. Now this is assumed to 0.4 meters. Say I want to do to 1 meter. So now if you see it's actually run to 1 meter, right there. Now so that's that. Now, if we actually wire by selection, these 3 will be in 1 meter. So I go 1, 2, 3. I've got them wired. Now, how will the wiring actually go? Say I want to wire this to the ceiling anyways. So start here. And for argument's sake, let's assume that, we want to get this, for example, let's have it run here, here. Let's have it run straight up actually and meet the distribution board somewhere around there. So now what I am going to do is I'm going to select this one, which is the cable run plus all of this. I will say DB1 and this is FC2 assigned. So 3 symbols and 3 wires are assigned and apply. So now you see 42.13 and final circuits 0.3. So currently we have set a double socket to be a single utilization point. So if I do select similar properties and I change this to installation points 2, now it's automatically 6. And if I apply, that goes there. Now, if I shut the CAD plan add-on and I go to my circuit edit, you can see I've got 6 into 200 watts and 42.3 meters. Now, automatically it tells me what is the load required. Now, you see if I increase this to say 1000 watts, sorry, automatically it's now telling me that I have an issue. I can no longer use this. Firstly, my load current is exceeding the protected device rating. So say if this was 700, that's still an issue. Well, is it? Yeah, it's still an issue. So yeah, so we'll take it as say 500. Yeah, that's not still an issue actually. Even 700 is not an issue. That's just a different warning. I'll show you what I mean. So what it's essentially telling us is that we have a design current of 18.26 amps. There are devices only rated to that much. So if I change this to say 500 or say 500, I don't have that issue anymore. However, it's flagging a voltage drop issue. So if I go to voltage drop and I've seen I've only allowed 3.5% voltage drop on this. I can obviously user define it, say I want 4% voltage drop, but I'm actually getting 7.2% voltage drop. If I increase this from 1.5 to 2.5, I'm still getting 4.57, which is relatively high. If I increase this now to 4, the voltage drop issue is going away. So that's how it actually works. And if we go back to our CAD plan add-on, if you observe in 3D, the whole thing is, modeled. Now, how do we actually translate this into a report? So I can generate a very fancy report from all of this. But say I want a circuit schedule, I want my main supply, let's have a cover page as well. Some cable schedule, voltage drop analysis, short circuit evaluation as well, earth fault loop impedance, a bill of quantities, uh, plan drawings as well, plan list of materials. So if I generate a report, obviously it's now giving me warnings because let me show you what the warnings are first. So yeah. So power factor obviously, and now it says that it is beyond the split limit, which is fine because I have set it to, well, 4% here. But this is now, if I go back to split limit, it's still 2.89. So if I, then I'll need to do 6 square mm actually. So now that warning will go away. And obviously I can, yeah. Now, yes, back to reports. So if I generate this report, and that's fine, it has warnings. I can add my own company logo here if I want to. So I'll just do that for the sake of showing you. So project info and options. I don't want to use Modixoft's logo because this is not Modix. This is my project. So let's say I choose our company logo. Yep, there you go. I can say TNG Electrotech Private Limited, office say Mumbai, engineer is me, is Theobald, save. Project title is say, I don't know, XYZ Factory Mumbai. Client is, I don't know, say Nandu. Yep. So now if I regenerate the report, there we go. That's what everything as well. So it gives me the supply characteristics. It tells me, these are the final circuits. These are the power factor harmonics. This is the load. If you want to add a diversity factor, any spare capacity. These are the cables that we are using. How are they installed? So actually, I will export to PDF and then I will just do that so we can actually see it separately. There is on my desktop. Documents, report, export. Export complete. There you go. Right. So, it gives me all of this information. This is the cable used. This is the voltage drop we're getting. Now, does it pass the short circuit evaluation? So, we are allowed, this particular device is a 15K breaking capacity. This has a 10K. What is the actual short circuit current maximum? So, does it pass? This is the protected device. So, this is the time it will actually disconnect in. What is the maximum time we're allowed as per NEC? And it says, IEC 60264 right now. Maximum, this is a maximum for loop impedance allowable. So to actually use, this is where we're actually at. If you did it to 80%, this is where we're at. Yeah, if you can add in prices also. So this is a cable required. This is a conduit required. It can give us a pricing as well. Yeah. So, and this is obviously for the sockets we've used. And it actually generates a nice little schematic as well. Flow plan, I mean, yeah. And that can also be exported separately. Anyways, that's about it I had to show you. Nandu and Lakshmi, how are we doing?
We are doing great. We got some good number of victims.
Okay.
Yeah, we have question. Krish, did you run a polling in between?
Oh yeah, it's a good thing actually. Yeah, I don't believe we actually done the polling. So we want to actually understand what software you guys are currently using right now. I mean, I hear a lot of ETAP. Some people have said Pro Design as well, but I want to know actually what you guys are using. So perhaps we could run a poll in the audience.
Lakshmi, can you do the polling? Can you put up polling? Yeah. So we can start the polling now. So it is just kept for a few seconds, I think. Only 9 seconds. Yeah. Let's see how many people vote for this. So to the audience, just click where you can, so that we can get maximum result out of this. We have another 40 seconds to go. I would urge all the participants to do your voting on this. Okay, we can end the polling. Let's result, Lakshmi. Yeah, the result shows. This is for you, Krish.
Okay, I can see it. Yeah. Okay, so basically, most people use AutoCAD as expected. Um, some people are using international software machine, they're using Pro Design or ETAP, something like that. And some people are not. So I wonder how you're doing it. Does your software comply with the national electrical code? Some people say yes. Nandu, is that you? Have you said yes? I don't know what other software is available in the market that actually complies with NEC. Do you want the
Do
software? Yes. Yeah. Sorry, Mr. Dominic.
you have any more, any other polling? The only one polling, Lakshmi?
Yeah, only 4 questions. So that's it.
Okay, fine. Okay, good. This good statistics for you to understand, Krish, where where we are heading. Uh, I will just go to all views, galleries, which you can see. Okay. Now I would request. We have a good audience who can put a question, and also if you can raise your hand, I can allow you to talk to Krish and direct interaction you can have, so that you can down menu, you have a raise hand. If you can raise your hand, I can probably take you to the conversation. So let me see, is anybody here now? Lakshmi to host. Okay, raise hand. Participants, we have 6 attendees. Amit Kakarji, sir, you are the first one to raise the hand. I'm going to allow you to talk to our speaker. Ask to unmute. Sir, if you are hearing, if you are hearing me, you can unmute and talk to
Yeah.
Krish. Yeah,
Uh,
go ahead, sir.
First, I would like to congratulate Krish for his wonderful presentation. Yeah. Actually, I raised a question. I raised my hand initially just to inform him that his voice was quite low. But
Okay,
actually, I was not asking any question. That was the thing why I raised question initially.
okay. That's
Thank
good. That's nice, sir. And thanks for joining. It's a blessing, such a senior person from Rajasthan.
you.
And you are a regional director of NFE. I'm sure this software will definitely help all the participants, and especially the consulting community who are designing various buildings and industries.
Thank you. Thank you.
Okay, Rajesh Goyal, I will ask you. I have allowed you to speak. You can unmute, Rajesh. You can go ahead and speak to Krish. Okay, Rajesh is. So I'm asking Amrit Lal to unmute and speak to Krish.
Yeah, good morning all.
Yeah,
Hi.
get a
Hi.
bit
Hi.
louder, sir.
Krish.
Yeah.
Yeah, good morning, Krish. My
Morning.
question is two, three questions. One
Sure.
is about the voltage levels. Drop levels are
Okay.
predetermined by us, or it is totally cumulative? It is calculated and it will correct automatically.
So there are two ways of doing it. Basically, you can set a predefined value. Well, you have to set a predefined value, or you can use whatever the software does. But in most cases, there are two options. I will show you. Yeah, one moment, please. So I will just open the software and I will show you how that works. So I go to electrical OM. Just a moment. Just open up the project we just did. Yeah. Right. So voltage drop. So say on this circuit, right? So there are two ways of doing it. Number one, I can say that I want a certain voltage drop at a board and a certain voltage drop at the final circuit and any extra allowance. So this comes total 5%. So this is there.
Yes.
Number two, I can say I want in this circuit, I say I want only 2% voltage drop. Now, if I put 2% voltage drop, you see it will flag a warning because it's actually 2.01 here. So I can set either remaining from the board and I can set a predefined. So for example, here, if I say remaining from the board, 1.5, 3. So I'm because it's a socket circuit, we are allowed 5%.
Yeah.
So if I go to the board now and I select voltage drop, here I say 1.5%. So if I change this to say 1% and I go back here, now see 1 and I get 4% here. So it is entirely dependent on whether you want to set it individually for the load for the final circuit or you want to set it for the board. It's up to you how you want to set it.
That is okay. It's clear. Now the
Yeah.
second question is: are we actually in the software talking about voltage coordination level?
Sorry,
Voltage coordination level.
could you
I
be a
mean
little
the
more?
service
Yeah.
entrance switchgear will have a different impulse withstand, and inside DB you have a different impulse withstand voltage.
Correct.
You don't need to have the same kind of voltage impulse withstand level for all switchgears.
That's correct. So this software is primarily a calculation engine. So stuff like the impulse withstand level, you can enter onto. So for example, what I
No, the
can
thing
do
is,
is
why I asked this question, because you have a library of products.
yes.
The library of products will have the voltage level as well.
Okay.
I think it
So
will be very easy if we select the wrong
that
product. It can
yeah, so
flag
that
a,
can be added. So the thing is, obviously, the library is very dynamic. So say for example, tomorrow you want to add a product that's not in this library, you send it to us, and we will add it within a couple days. So then, obviously, impulse system, everything will come into the picture. And obviously, if it's not there, software doesn't do those calculations because there's no calculation to actually run. But you can enter that information so that it comes in your actual reports, etc.
yeah, okay.
Yeah. You had a couple other questions as well.
I think initially you have shown some DS symbols, and this right
Where?
now what I am seeing is now EC symbols.
Yeah,
Earlier,
no. That was just something
yeah.
in the. It was a reference to a guidance note. Actually, that was not a
Okay.
BS symbol. It is the IC only.
Right.
Okay, thank you, Amrit Lal. Thank you for interacting with him. So I'm going to
One more.
lower your hand. Rajesh Goyal, if you're still there, I'm allowing to talk. If not, I'm going to lower your hand. Yeah, Rajesh, go ahead. Please go ahead, talk, Rajesh Goyal ji.
Yes.
Yeah.
Yes, Mr. Rajesh, please.
What's your question, sir?
This is a very good software, and I'm using a ETAP earlier, and
Okay.
I think this is something different from ETAP.
Yeah, absolutely.
Yes, and it's require a lot of engineering for me, and definitely it will help me to resolve all type of selection of the cables and switchgear selections of the and let's try. how it will work for us.
Mm-hmm.
Thank you, sir. I think for a good question, he will give a free trial. Those who are coming out with encouraging words, I'm sure Krish will give you a free trial to experience how it looks. I'm just requesting. There are a lot. I know, developing a software to this extent complex is not that easy. But I'm requesting Krish for people who have shown interest and appreciating, because it is in compliance with the National Electoral Code of India. I think you should give free trial for maybe 15 days or 1 month to those who really wants to use the software. Let's hope our Krish will extend that later, one-to-one interaction. Yeah.
Yes.
Okay. Thank you, Rashish Goyal ji. And Amrital is done. Rajan Menon, you have any question to ask? I'm unmute. You can unmute and talk.
Thank you, Krish, for your great initiative on this sector. And I have a suggestion that along with the BOQ, we should have analysis for the labor component also, which we will be able to abstract from CPWD data analysis manual. For each and every work, we will be having a separate contribution for the labor part, helper, labor, those things are already available. If it is also incorporated to the software, we will be get a clear idea about how this execution part will be costing, how expensive this installation will be. So that also an added thing, and it will be very easy to formulate estimate for any work. And the report is in the technical part, which the end user may not be so much of interested, but he will be interested for the cost incurred for this particular installation execution. So we will be having a BOQ with some the price list already we can incorporate, I believe. And if the discount terms are dictated, we will get a clear estimate for this. Any possibility for that? Please elaborate.
So currently, like I said, it's just a calculation engine, but your comment is noted. Obviously, it's very interesting. So yeah, definitely, we'll keep. We have noted that point, and we'll see what we can do. Thank you.
Okay. Thank you, Rajan sir. Narendra, if you're there, probably I'm going to unmute and I'm allowing to talk to you, Narendra ji, so you can talk to Krish.
So good morning, sir. Mr. Krish, very good morning.
Good morning.
Hello. Is it
audible?
Yeah,
good morning. You're
audible. Yeah.
Yeah. In fact, which AutoCAD version is suitable to import the file into this software?
It doesn't really matter as long as it's a DWG or DXF file. Even a PDF file is fine. It doesn't really matter.
Sometimes we used to get the electrical drawing directly from the architect. Say, for example, they used to plot the light fittings, switch ports, and everything.
Yeah.
Is that useful for us to import?
Absolutely, that is very useful, because once if you have the locations, right? Yeah. First, what you can then place the symbols here exactly where they have placed that. So ideally, you want the architect to give you the diagram for the load.
Exactly.
That way you don't have to figure out where to put the load. I just did that as a sample to show you. But normally, what happens in a building site is that you get a floor plan with the lights are here, sockets are here, air conditioners are here, everything is here, and you just drag and drop there and put it.
So in fact, we have not gone through this software earlier. I have one more doubt, sir. Okay. Can we make the drawings for industrial purpose also, having cable tree erection, something like that?
Yeah, absolutely. Any low voltage up to 1000 volt AC, 1500 volt DC you can do on this software.
Right, sir. Is there any training available to undergo?
Yeah, we are coming up with something. We will keep you posted on that. Yeah.
Fine, sir.
Where are you based, sir? Narendra sir, where are you based?
Tirupati Balaji, sir. I already spoke to you quite some time ago.
Yeah. Oh, tell her.
I'm the oldest NFE member, first 100.
Very good, very good. Yeah, nice, nice. Thank you so much.
Good day, sir.
Thank you.
Thank you, sir. Thank you, Mr.
Yeah. Pankaj, I'm going to unmute if you want to talk to Krish briefly. Pankaj, go ahead and talk to him.
Yeah, hi Krish.
Hi.
Krish, I want to know that I am a little bit industry person. So
Okay.
in some cases, there are some machines which are exported or some machines which are having panels. They are automatically getting tripping or some uninterrupted alarms are coming. So
Okay.
can you put that circuit in this software which can give alarming that due to earth fault or due to any other looping, something like that, it will happen and the circuit get tripped or panel get tripped. This type of activity can we do in this software?
So the software only allows you to model a correct installation. So if you're trying to model an incorrect, if you're trying to create a simulation of a wrong, of, say a wrong connection or something, you can't do that. However, you can model your installation and simulate fault. So that is an option to be done. But obviously, you cannot. It's not that you feed in all your data and it will tell you why it is tripping, because it will only allow you to do the installation correctly. So if you're trying to simulate a fault, like a wrong connection, say between line and neutral, or neutral and earth, that cannot be done because it's a modeling software for design, not a retrospective fault finding thing.
Okay, okay. So, yeah, that is because in some cases when there is already installation happened and we need to check sometimes because there are so many things or so many faults happen. So might be you are saying that it is checking as per the NEC and after that.
Yeah. So you can model it, and whatever is relevant to calculation, obviously you model it. It cannot tell you that, for example, one lid is missing on a box or something like that, or
No,
the
no, no.
cable is not mechanically protected. But if you
Okay.
model the installation retrospectively after the installation is built, any calculation related issue it will flag. Like it showed me when the respective
Okay.
fault current was higher than the required, higher than the withstand. It will flag it. So yes, retrospective design can be done in that sense.
Okay. Okay. Great. Great. Thank you. Thank
Yeah.
you.
Thank you, Pankaj. I'll take the last live questions. I think we don't have last this will Imran. Okay, Davis, you wanted to ask you a question. I'm going to unmute. Davis, you can talk to
Q&A,
Krish.
in the Q&A, there are some questions as well.
Yeah, I will take after this. Davis, if he wants to talk to him, you can go ahead and talk. Okay, I'm also happy to see Mr. Gopakumar, the president of NFE, also joined. And while we take questions, I welcome. Maybe you can do a small vote of thanks because you're also part of this seminar, that is ongoing seminar, speaking how this software will, complement the effort of good design of the circuit. So I will take the questions. Amrital is already done. Krish. Krishnan is asking how minimum fault current calculated.
Yeah. Okay. Sure. That's a great question. So I'll show you again. So minimum fault current is essentially calculated at the extremity. So if I go back to my schematic here, let me just share my screen. Zoom. Zoom.
Sir, Gopal sir, can you take these questions? I'll just come back in 2 minutes.
Yeah.
Yeah, I
So
can
minimum
take a
fault
photo.
current is shall I continue?
Yeah,
Yes,
please
Krish.
continue, Krish.
Yeah. So say for example, I have a transformer, right? And these are my transformer for characteristics. I have a fault current uh, contribution of this transformer. If it is a low voltage supply, I have measured the earth fault loop impedance and the respective short circuit current, so I know what its contribution is. How does it calculate minimum fault current? It what it essentially is doing, it is saying that I have a cable for this much. This is the resistivity of the cable. This is the impedance contribution of impedance to that sorry, the reactive component to that. Then it says that this is the temperature of the conductor, and then this is the fault current. So for example, you see here, phase fault, I have a starting point 22K and an ending. So according to IEC 60909, it has applied a 1.1 factor. So 20K times 1.1 is 22K. Then max ISC at endpoint of this 3 meter run is 10K. minimum ISC is 3.7K. So now if I change this length to say 20, you see all these values change accordingly. So that is how it is running the calculation. And accordingly, it will say, okay, this is the fault current. So this is the amount of electrical energy. Conductors can withstand this much. Earth fault current is this much. Current causing operation of electric device required is this much. This is the earth fault loop impedance. This is the time it will disconnect. So all that data is calculated basically based on source characteristics and length of the conductors to the point of fault, to the extreme point. That is how it calculates.
Okay, I think Sir Dominic is there. I think he's not there. Krish, am I audible, Krish? Krish,
You're very audible. You're very audible.
Yes.
Because I am traveling and in the car and.
Should I take up the question, sir?
Yeah, I can read. As usual, we have a very interesting question. Is there any calculation for how many earth pits connected to my 300 milliampere electrical loaded system? I think this confusion is never going to end. Probably we don't need to answer. Or you'd like to answer this question?
Yeah, I will simply say that why do you need earth pits? Okay, if you have a TT installation, yes, you can input an earth electrode if you want, but say this installation I made it as a TT, then I can put in a resistance of earth electrodes, 50 ohms or whatever, and that's fine. But as long as you have as long as you have the relevant earth electro uh, anything below to ensure that automatic disconnection facilitates, you can input the earth electrode resistance. But yeah, and I change this to TT, and I can add an earth electrode if I want to. And as long as the value facilitates earth fault loop impedance, then no problem. Now, see if I 50 volt, now again I'm giving issue. So it's saying that this circuit cannot disconnect. So then I need to add a RCD. Say I add an RCD, make it a I don't know, say 63 ampere RCD with a 500 mA. Then that warning will now go away because yeah. So essentially that's how it works. But now it's giving me an issue here. There is nothing here. So now I will add an RCD here again. So here I will probably need to add a relay. So say 300 milliamperes here. So that's happening. Now it is giving me a warning because both are this thing. So if I go here, I say earth leakage relay adjustable and whatever. So basically you get the point. I can add an earth electrode, but how many earth pits are required? That is a ridiculous question because that is not a matter for low voltage installations in any case.
Krish, then there is a question. Do the software takes account the severity classes that you have explained at Surat workshop for the selection of the protective device?
You mean the rating factors? Yes, absolutely. So again, I will show you. Just a moment. So if I choose this circuit, for instance, I can go to the correction factors and enter CA, CG, CH, CUV. I can enter all of these factors. Is it bunched? How many circuits? All of these are obviously taken. Obviously, you can't do electrical design without this.
So basically that question is answered. Yes, it's possible.
Yes.
There is a question from an anonymous attendee. If there is any possibility to make it more India specific in terms of the type of CPC material. Currently, I believe that only copper, aluminum, while India being cost sensitive. The question is whether the PE conductor, galvanized steel, is allowed. Can be
So
made.
yeah, we are actively, so we are very open to adding materials and products. So yes, if you give us the details of the particular, so what is the resistivity, so on and so forth, as long as it is according to the standard, we can add that. That's no problem.
Okay. Well, the answer is yes, we are working on it, and GI, galvanized steel, also will be added as a PE conductor. Okay. I think there is no much serious questions.
There's already, the Purna Chandar is asking. Sorry. Okay. Purna Chandar, does the software have built-in mechanism to follow the IS codes and IEC codes, NEC and all that?
So the current engine is a 6.64 engine, like I said, very similar to NEC, but obviously we will make a couple modifications. And yeah, the software is also certified by the Chartered Institute of Building Services Engineers to follow the relevant standards. So yes. Yeah.
There are some questions in this. Hi, is this software works only building or can be used for substation designing also?
So no, this is a low voltage installation software. You cannot design a substation. However, you can enter the details of the transformer that will have an implication on the low voltage installation. That can be done. So like I showed earlier, I will just reiterate again. So if this was instead of an LV supply, if this was a transformer, absolutely, that's not a problem. I can add in a transformer. I can enter all of this information, calculate the short circuit current, calculate the power factor fault. I can do all of this. Obviously, it's a low voltage design software, so it's not going to help design a substation. However, the implication of the substation on the installation is what it considers. Yeah. We have a question. Sorry, we have a question on is a software can be integrated with Revit? Yes, absolutely. So just like we've done it with the internal CAD platform, it can be integrated with Revit, and there is a Revit add-on. So I will just show you. You go here, Revit, and you sync from Revit and or export to Revit. So, and there's also, we're working on Modicsoft is currently working on a feature where it syncs continuously. So basically what happens is whatever changes you make here reflect in Revit, and whatever changes you make on Revit reflect on the schematic and the calculation. So yes, the software absolutely syncs with Revit.
Okay, you were able to see the questions.
Yes. Yeah. Yes. Am I audible?
Yeah. Go ahead.
Yeah. Then is it be compatible with the eQuest simulation software that is popularly now going to adopt in LT distribution network for buildings other than industry in energy conservation building code regulations in Kerala?
Sorry, I am not familiar with that software. Actually, this software
is only an American software which is only approved. No Revit is approved in Kerala state for simulation activities for buildings. There is a it's all there is a acceleration to electrical design is available on that, but I didn't experience through that. But a simulation for a HVAC system is very, very beautiful for that, except that doesn't support the VRF machines. That's the only constraint. We will deeply discuss this matter with the Energy Management Center, Kerala, with the Electrical Inspectorate.
You can take this forward with Krish one-to-one later. Probably you can give some reference to him to have a look at it. So you can talk to him later, sir, directly.
Yes, thank you.
Okay, thank you.
Energy Quest is mainly focusing on the energy conservation point of view. Not only electrical energy, but all kind of energy in a typical building. So here what we are talking is pure electrical design based on NEC. So these two are little bit different subjects.
Okay. So over to you, sir. Gopkumar, sir, you want to say a few words, and what do you think about the software which will help our industry?
Yes. Thank you very much, Mr. Dominic, for inviting me. In fact, I just landed in Trivandrum yesterday, and day before yesterday, me and Krish, we had 2 days training in NITS, National Institute of Training for Standards. So there were participants from all over India on NEC capsule course, 2 days capsule course. So now this particular software, you see, during the last 2 years, we conducted at least 30 or about 28 1-day, 2-day workshops on NFE, several multiple 2 days capsule course in NITS of Bureau of Indian Standards. Then we also conducted maybe 50, 60 webinars. So in most of the place, the conclusion is the non-compliance actually starts from the design onwards. And the first fundamental thing like system earthing, from there itself, the confusion starts. Of course, the software is going to be very much useful for designers to make a perfect perfect design, which is in compliance with all the requirement of the NEC. So definitely this is going to be an useful tool with respect to safety point of view. With respect to the speed of work, it's actually a very useful tool with which you can, in a given time, you can, it's very fast to work with. You can complete your works very quickly. I think Krish mostly today concentrated like a design for a residential or that kind of a small office.
We just did a small. We just did one machine, so one drill machine, and one socket outlet circuit. Obviously, because we are limited on time. But you can go as big as you want. So if you like, I can show you a. Would you like me to show you one of a larger project where we've got many more circuits, and that shows you how much time we save. Would you like me to show that?
Yes, please. That means, even if there are thousands of circuits,
no problem.
It can be.
Go ahead, show, Krish.
Yeah. So, one moment. Let me just do this. Hold on.
Meanwhile, there was one question that I saw. ETAP, whether compatible to ETAP, chat box here.
Okay, so you see here in this particular instance, we have got a very large electrical installation. Well, not thousands of circuits, but you've got a relatively large installation. This is the main DB. This is your panel. We've got one circuit for heating, one circuit for an elevator, two downstairs DBs, one upstairs DB, and then the actual DBs itself have a variety of circuits. So, that's how it is. And if we look at our CAD plan and separately, you see so many different circuits. So if we look at the details of all floors, we have a very elaborate installation, So this can also easily be modeled, no problem. And it will save you a lot of time. The main thing is, you see, when we design electrical installations, normally you make you do something in a schematic or SLD, then it has an implication on the calculations, and then it has the implication on your BIM or CAD. Here, one change you make, it affects everywhere. Secondly, when you do calculations on a spreadsheet, how do you know that your calculations are actually right? So this software and the calculation engine has been certified by the Chartered Institute of Building Service Engineers. So lot of time saving and accuracy is taken into place. You only have to make a revision once and it revises everywhere on its own. Plus, once you're integrated with Revit and all, overall for your entire project, it makes your life much, much, much easier because, like I said, revise it only once.
Means you see, one of the challenge which designers face often is the changes. Initially, there is one style, then weekly once it keep on changing. With the software, I think it's very easy to make these changes and integrate into the other drawings.
Yeah, exactly.
So, yeah, go ahead, sir.
Yeah. with the software, the designers are able to make use of the software and they can make smart designs and economical. See, economics, the cost saving is also one of the subject which we need to seriously think, because in a lot of cases, this thumb rule calculations are, oversized devices are used. I think maybe if we look at 50-60% cases, in one of the case which I tried with the same software, all the devices and the circuits were oversized, too much oversized. So we could optimize the design to an extent that about 27 to 28% cost got reduced. So this is also a serious subject. So basically, time saving, cost saving, reliability, and perfection is what we are going to achieve through this software.
Absolutely.
Yeah. Thank you, Dominic sir. Please take over, sir. You are on mute.
Thank you, sir. One question, the last question is how this software is superior to ETAP, ETAP.
See, as per my understanding, ETAP is a model and simulation software. This is a design software that allows you to do design. So, yes, it is superior because, like we mentioned, you make a schematic, it runs the calculations, and then you sync it with Revit or you sync it with CAD. And the bill of material generation, everything is specifically tailored for the ease of use for electrical contractors and electrical designers. Whereas ETAP is a broader simulation software. This software is widely used in the UK and Europe, and in the UK specifically, this is the #1 software for electrical installation design in the country. The gold standard for electrical installation design is electrical ON without a doubt. So it is tailored specifically for designers. I'm sure once you try a trial version, you will immediately, it will be evident what the benefits of the software are over ETAP. Thank you.
Okay, thank you. As I said in the beginning, those who are interested to have a free trial of this software, I'm sure the speaker, Krish, who's also the developer of Indian version, can probably interact with you. So we have already given you the details of info@TG. What's the mail ID? I don't remember. What is the mail ID, Krish, of info@?
So that will be info@tgelectro.com. I can put it on the chat here.
Yeah. I think Lakshmi's already mentioned about that. So those who are interested, please email to them and they will revert back. Chat box info@tgelectro.com. They will get back to you. Thank you, ladies and gentlemen, on this weekend for joining. A very good response and very positive feedback we are getting today. And this is another step of making proper electrical installation as per the NEC. So it's a part of awareness program that we conducted today. So we look forward to see you for forthcoming webinars. We are doing one great seminar on 5th on Grenfell Tower fire lessons on electrical, on the sustainable facade, everything. So we're getting all experts, and Mr. Gop Kumar also will be participating in it. And we have given the link on the chat box, those who are interested to be part of that. So please do join us. We look forward to see you again. Thank you so much. Have a wonderful weekend. And we will be sharing this video to all of those who are registered. Thank you, Nandu, who's back end supporting us. And thank you, Navya and Lakshmi, for supporting from the back end. And wish you all the best, Krish and Nandu, young guys and true startup company and helping for the nation to be electrically safe. So I wish you all the very best. Thank you so much for coming forward and talking to us. And let's see. And as we move on, we can probably version 2, version 1, we can again come back and present it more dynamic. And look forward to see you again. Thank you so much. Have a great weekend. God bless you all. Bye-bye. Thank you.
Thanks.